I had a question about number 11 on the homework. And first off, what is the socially efficient number of kayaks? That's going to be our basic efficiency condition, that price should be equal to marginal cost. Remember, we had that unit on perfectly competitive markets, and we found that price equals marginal cost was supply equals to demand. Remember that demand is where the marginal value is found, and supply curve is where marginal cost is found. Anyway, marginal value, marginal cost, or price off the demand curve is equal to the marginal cost. That's where social efficiency occurs. So we noticed that Suzanne's marginal cost of renting out a kayak is $20. So for social efficiency, every person that values renting a kayak more than 20 should get it. That means the socially efficient number is 7 kayaks rented out each day. So 7 should be your answer there. Now, the little bit harder is the single price monopoly problem in this format. And I don't know that we've done one of these in class. This is our chance to do one. So the easiest way that I know how to do this, I'm not saying it's easy, it's just the easiest way to do this. And I'm pinched for space here. What we'd like to do, remember, is to invoke that rule where the monopolist maximizes profits by setting output to where marginal revenue and marginal cost are just equal. Or another way to say that, every kayak rental that produces marginal revenue greater than marginal cost should be rented from Suzanne's profit maximizing point of view. Any kayak that yields marginal revenue below less than 20 should not be rented from her profit maximizing point of view. Notice that her profit maximizing point of view is not the same as the social optimum rule, but it's the Suzanne optimal rule. All right, so to do this, we need to calculate total revenue, and then from there, it's easy to get marginal revenue. Total revenue, remember, is just price times quantity. Marginal revenue is equal to the change in total revenue divided by the change in quantity. And we're going to see that the change in quantity is always one new customer as she drops price. Everybody that values the rental more than the going price will rent one. So this is essentially our demand schedule. When we have a demand curve, it's in a graph. When we have a demand schedule, it's in a table. All right, let's fill out marginal revenue. Let's get to total revenue first. Notice that 85, I don't know if I can write small enough for these. 2 times 75 is 150. 3 times 65, 195. 4 times 55, 220. 5 times 45, 225. 6 times 35 is going to be 210. Notice that marginal revenue is going negative. Just for completeness, let's fill out this table. 175 and 120. 8 times 15 is 120. All right, marginal revenue, given that the denominator is always growing by 1, we don't have to worry about that in this case. Watch out for that on a test, though. Change in total revenue is 65 divided by the change in quantity. In this case, it's just 1. That marginal revenue is going to be 65. And what we notice here, 65, 45, 25, 5, negative 15, negative 35, and negative 55. There's a regularity to these that you'll notice once you do a few of them. Well, we noticed that if by our rule, every kayak rental that produces marginal revenue greater than 20 should be produced, no more than that should be produced. We noticed that her optimum is to rent 4 kayaks per day at a price of $55 per kayak. Now I had to go to a new page just to fit this whole problem in. So let's flip the page. I might have to come back to my table here, or actually add to my table here to do this problem. In fact, I didn't leave myself quite enough space to do that. Oh, I can erase though. All right, we're gonna have to look at her problem, just maximizing over the people that wouldn't buy at the full price. So it's this group of people as a separate market, essentially. These are the people that might or might not use the coupon. So I'm gonna erase this this scribble over here. Am I not? Somehow I can't erase that. Let's just do it. Total revenue. I hit my palm on the Add Pages button there. Sorry. Let's look at total revenue prime, and because I can't erase that other stuff, I'm going to put marginal revenue prime over here. And we're just looking at these customers here. Pardon the messiness. And so if she drops the coupon price to $45, so she gives a $10 discount, she's going to get one new sale, and that'll be 1 times 45. The total revenue from the coupon sales will be 45. If she drops price, on the other hand, to 35, she'll sell 2 coupons sales, and that the revenue there will be 2 times 35, or otherwise known as 70. If she wants to wants to drop the coupon price to 25, she'll sell 3 at that price. We notice that 75 is the total revenue from that. And if she drops all the way down to $15, she'll sell 4 coupon sales, 4 discount sales, and that'll be 4 times 15, that'll be 60. So we can do the marginal revenue same way, 45, and then 25, same regularity here, 5, and negative 15. So the best she can do on selling coupons, it's the same maximization problem. She'll drop the price on the coupon as long as the marginal revenue from selling that extra one is greater than 20. It turns out that the coupon price is going to be 35, so she'll give a $20 discount, and she'll sell 2 more at that price. Let's go back to that. All right, here we are. Notice that for the full price buyers, they paid 55. Four of them paid 55. So CS full is equal to 80. First person valued at 85 got it for 55. $30 of surplus. Plus second person got $20 of surplus. Verify that, plus 10. So that is 60 units of consumer surplus. Once she offers the discount price, notice that discount price was 35. 2 people bought it. One of them had valued it at 55, at 45, only valued it at 35, got 10. So that's 10 more. And so the total for the combined full price and coupon price, that's 70, which is higher than 60. So we've proven that. All right, on to the next one. Wow. All right, now suppose Suzanne offers to give a discount to customers who fill out a customer satisfaction survey. People with reservation prices above 45 never fill out the survey. Those with reservation prices of 45 or less always fill out the survey. How many kayaks will Suzanne rent out each day? What price should she charge to the people who do not fill out the survey? And what price should she charge to people who fill out the survey? Well, it's pretty convenient. People with reservation prices above 45 will never fill out the survey. So maximizing over that group is the same as our previous problem. So she's going to charge $55 per kayak to that group. The challenge here is what's going to be her coupon price or her discount price. And let's figure that out. For that, I'm going to need to go to the previous page, previous worksheet. And I had to scroll past those empty pages. Here we are. So she's going to sell, the discount price is going to be now $35. And so she's going to rent 4 out at full price, 2 out at the discount price. So her total kayaks rented is 6. And then is consumer surplus higher? We know that it is, actually, as long as any of the coupon buyers got any surplus, then the full price buyers are the same as before. There was some consumer surplus there. She's made new sales, new consumer surplus. Let's just, for completeness, go back and figure out the consumer surplus in the two cases. Consumer surplus is higher when she price discriminates. Let's just verify that, and we'll call that good enough for this screencast.